Okay, so we've looked so far at y-intercepts. Who can tell me what a y-intercept is? Yep. Okay, so it's where it hits the y, what do we call the y line? Y-axis. So what do you think an x-intercept is going to be? Where our line hits the x-axis. So that's the definition of an x-intercept, is where our line hits the x-axis. On the x-axis, I know that every point on the x-axis, there's something particularly special about the y value. What's special about the y value? Everywhere on my x-axis. What can you tell me about, what's the y value here? Overwhelming silence here. Okay, what about here? What's the y value here? Zero. What if I go across a bit? What's the y value?
2, 1, whatever you want.
The y value. 0, because I haven't gone up or down, have I? Does that make sense, Callum?
Yep.
So even though I've moved across here, yeah, my x has changed, 1, 2, x is happening, something's happening, but the y is not changing. So everywhere on the x-axis, okay, y equals 0 on the x-axis. This is really important because now I don't need a picture, Bryce, to find the x-axis. Okay, so if I have the picture, this is really easy, isn't it? I have to find where the line hits the x-axis. I go to my picture and I see the graph and I see, oh, okay, this is a -1 here. So my x-intercept is -1. Super easy. What this means is I can find the x-intercept from the equation because I know if y equals 0, I must be on the x-intercept. So if I had an equation that said y equals 3x minus 6, okay? Just an aside, looking at that, what's the 3? Who remembers what the 3 is? What does it represent?
The gradient.
The gradient? Yeah, Bailey was... and what's this one? The y-intercept. Okay? There's nothing there that obviously tells me the x-intercept, but because I know that y equals 0 on the x-axis, I'm going to take my equation and I'm going to make the y as 0. So I'm going to put y equals 0 into this equation. So that would give me 0 equals, oops,
Go away, keyboard.
3x minus 6. Does everyone see what I did there?
No.
All I've done is I've substituted y equals 0 into my equation. I now have an equation that I can solve. You guys are awesome at solving equations. So tell me, what should I do first?
-6.
Plus 6. I'm going to ignore that you said minus.
I play plus.
I said plus 6.
What do I do now?
Divide by 3.
Divide by 3.
2 equals x.
Abby,
You got it wrong.
X equals.
Are we all happy that x equals 2?
Yeah.
Okay, so I know, even without drawing this picture, that it's going to cross the x-axis at 2. So this is my x-intercept. Now that's kind of cool because I now know 3 things about my graph. I know the gradient, the y-intercept, and the x-intercept. That creates a 3rd way of drawing our graph. Now we've already looked at drawing a graph from a table of values. With Mr. Blythe earlier this week, you looked at how to draw a graph using the gradient and the y-intercept. So today we're looking at a 3rd way to draw our graph using the x-intercept and the y-intercept. So on my graph, which of course you would draw beautifully with a ruler and a pencil. Okay, so here's my graph. I know that it's going to cross the x-axis at 2. Okay, so if I go across my x-axis, I know that it's going to have to cross here. I also know that it has to cross the y-axis at -6. So if I go down 6, which of course you would measure out nice and neatly, then I know that it has to cross here as well. So all I do now is I grab a ruler, and I'm not going to grab a ruler, I'm going to cheat and just draw a line.
That's cheating.
Okay, so I'm grabbing a ruler, and I know if my line goes straight through these points, then I have... Alright, so that's a bit dodgy.
Dodgy.
Okay, so we'll just straighten it up a bit there. How's that?
I can't see on
You
the
would have to use a ruler, right?
Okay, you would use a ruler and a pencil and you'd make it beautiful. So this line is now the graph of... Go back to the pen.
Oh, and then you can find out the gradient too.
This is y equals 3x minus 6. Did you see how quick that was to draw?
Really quick.
Because all I knew was the intercepts. I just grabbed a ruler, I'm done. Okay, so now you have 3 ways of drawing a graph. From the table of values, from using the gradient and y-intercept, and then from the 2 intercepts. Can anyone think of an equation that this is not helpful for, this third method?
Angles.
There's some graphs that is really unhelpful.
circle graph.
No, it's a straight line. What about this one? Okay, y equals 4x.
Yes.
What's my gradient?
Multiply 0 by
4.
What's my y-intercept?
X.
What's my y-intercept?
0.
0.
The big fat 0.
Okay, how do I find my x-intercept again? What did I do?
Go. Like, y by 4.
How did I find it?
What did I do?
It's invisible.
How did I find it back here? How did I find this?
Why you added 4 on both sides?
You added the y-axis.
How did I find it?
Y equals 0.
Y equals 0.
I put y equals 0. Okay, we're one way
Said
down.
that.
Okay.
Yeah, that's what I thought y equals 0 was just the example.
Okay. X-intercept, okay? The can't spell. Intercept is always when y equals 0.
Yeah.
So 0 in here. What does x have to equal? 0. Okay, I have the x-intercept at 0.
Yes.
Girls. The y-intercept is 0 and a gradient of 4. So if I try to graph using my intercepts, it's not going to work. Why? Okay, so I find the y-intercept. Where is it? I find my x-intercept. Where is it? Okay, I cannot use the 2 intercept methods if there's only 1 intercept. So in this case, I'm going to use the gradient and the y-intercept. So I know that I've got to start here. I know my gradient is 4. What does a gradient of 4 mean?
It equals 4?
That's rise over run.
Yeah.
So what's my run?
4. 1.
1.
1.
Because 4 on 1. Shh. Michelle, you need to focus. Okay? So my gradient is 4 over 1. So I put from this point, count up 4, go across 1, and there's my second point. So that's what you were doing with Mr. Blythe last lesson. So I can now still draw my graph.
We had this rainbow and then
Yes, you did.
and then.
But this is the lesson you did with Mr. Blythe, okay?
I wasn't even here.
Everyone,
That's funny.
does everyone understand why I had to draw that one differently?
Yeah.
Because I couldn't find a different x and y intercept. Okay? How do I find the x intercept? What am I going to put? What 0? Yes. So to find the x intercept, you're always going to put y as 0.
Yeah, y equals 0.
Alright, last example. I have the equation, oops.
Me as Ken,
You
I'm
need to
confused.
flip
Can you
off.
start again?
Yep, we're going to do another example.
Yeah,
Let's see how we go. Alright, Let's try this one. This is my equation. Okay. Shh. This is my equation. Stop touching the table.
What am I doing? I'm putting.
Don't touch
Yep.
the table.
Yep.
He's shaking.
Bailey, do you understand, Bailey? I've asked you not to do that.
Do all.
Thank you.
Sorry, ma'am.
This is the equation of a straight line.
Yes.
It's not in y equals mx plus b form, so it's not easy to see what my gradient or my y-intercept are. I want to find the x-intercept and the y-intercept. How do I find the x-intercept?
0.
What 0?
The reasonable 0.
Y equals 0.
Yeah.
Okay? So I'm going to go up here. Everywhere on the x-axis, y is 0. So if this y is 0, what do I get? I've got 4x. Do I need to write plus 3 zeros?
Hold this 3 0.
I don't really need to say plus 3 zeros because it's nothing. So it just equals 1. You need to have all these notes written in your book. If you can't do it now, you have to practice writing notes at lunchtime. I expect them to be done. So,
I've already done it.
so once I put y is 0, I get this equation. That's not very hard to solve, is it?
It's like last week's.
What's the answer?
Sign tax error.
0.25.
0.25?
Yeah, crushed it.
Is everyone happy with that? Okay. How do I find the y-intercept?
3 in a row.
Y-intercept. Every,
Wouldn't it be 3 repeater?
very good. X equals 0. So if I put x equals 0 in here, I have 4 zeros. Do I need to write down 4 zeros?
No, you don't. That's just a waste of
So I just go to,
Y equals 1.
so what does y equal?
0.33 repeater.
So, on my graph, I need to be really careful here. So this is 1, this is 1, this is minus 1.
Oh, don't worry.
Shh. So I need to know where is my x-intercept. It's at a quarter. So that's 1, that's up to say quarters here. My y-intercept. Okay, that's why we're going to do more examples. Okay? Adult. So do you understand that y has to equal 0 on the
You
x-axis?
just make
No,
it 0.
I'm still
Okay, so look at your x-axis, Abby. So this x-axis here, okay? Anywhere on your x-axis, you haven't gone up or down, have you? You've just gone across. So if you've only gone across, you cannot have a y value anything other than 0 because you haven't gone up or down. So what we're saying is in our equation, if we put y as 0, we know what the x value is on this line. Because on this line, y must be 0. Do you understand that y has to be 0 on this line? Do you not understand? Do you understand that y has to be 0 on this line? Because if I change y, if y goes to even 0.2 or something, I've gone up or down.
Oh my god.
Because we want to know where we hit this line. Okay? And we know we hit the line when y is 0. Okay? What happens on this line?
X is 0.
The y, that's just the equation. You were given that. So you are given this equation. Okay? All we've said, to find where you hit the x-axis, the y has to be 0. Once we did that, we got a really simple equation to solve. Yeah, which was pretty easy to solve. Yep. What we did then on the y-intercept, same idea. Everywhere on my y-axis, I've not gone across it all, so x had to be 0. So I said in my equation, that x has to be 0.
I get the x bit, but isn't y supposed to be 0, so how come you get the y?
In which one? This one?
Oh, to find the y intercept.
To find the y. So I'm doing a separate thing here. Now I'm finding the y-intercept. I've said, okay, x has to be 0. That gave me a y-intercept of 1/3. So on this graph now, my y-intercept would be there. Does that make sense? And then I grab a ruler and I draw the line. We got it? Yay! Okay, so this is my, you of course would have a much better line drawn with a ruler. Shh! Charlie.
I didn't even use cheat.
So this line would look much nicer because you'd use a ruler. And this is the equation 4x plus 3y equals 1. Okay? We do one more example. Okay. Alright, one more example. Shh. Year 8, why am I still waiting for quiet? Okay, another example, let's say I have 4x minus 5y equals 20. Okay, it's a straight line. I need to find my intercept. So we're going to start with the x-intercept. For the x-intercept, I know that y equals 0. Is everyone happy with that step?
Yes.
Yes. The next step, shh, you need to stay focused here, Ava. The next step is replace y in my equation with 0. So it becomes 4x minus 5 zeros. I'm not going to write minus 5 zeros because that's not needed. Equals 20. We know how to solve that equation. It's a basic equation. We divide by 4, giving me x equals 5. So I know when y equals 0, x is 5. How would I write that as a point?
Is
5, 0, like this?
Yes.
Yep. Okay, y-intercept. Shh.
Y.
Well, guys, this is the last example, then you have to try some.
X equals 0.
Y-intercept, x equals 0. Well done. So, on my equation, well done. So I get negative 5y equals 20. What do I do next, Bryce?
You times it by 5.
I've got to get rid of the minus 5.
So you divide it
Divide it by. So I'm going to divide by minus 5. What does that give me?
5.
What's that written as a point?
0.
0, negative 4. Careful because of the y value and the x was 0. On my axis. Okay, so on my axis, Mason, on my axis I have 5, 0. So 5, 0, that's over here. Okay, so I've crossed at 5. On my y, I have y equals minus 4. I've crossed here. I grab a ruler,
Draw a line.
which I better use my ruler this time so it looks prettier. Grab a ruler and I draw a line through my points, which I'm sure you have seen better lines. There we go. There's my line. Does that make more sense now?
Yeah.
Alright, your turn to try one. Okay, can you stop the video, thanks? Okay, so